Good evening, Titans. This is Mr. Simpson, and we're going to begin Chapter 5 tonight with Lesson 5.1, Solving Systems of Linear Equations by Graphing. The essential question is, how can you solve a system of linear equations? Well, let's first just learn what we're going to figure out tonight. And tonight you'll be able to check solutions of systems of linear equations, solve systems of linear equations by graphing, and use systems of linear equations to solve real-life problems. But it might be important to know, first of all, what is a system of a linear equation? So a system of linear equations is a set of two or more linear equations in the same variables. And here's an example of a system. A system just means two or more linear equations. Now again, this is something you want to make sure is in our journal book. So open your page or journal book to section 5.1. Find the vocabulary page and list these two vocabularies in there. Put the definitions in there, please. Again, the solution of a system of a linear equation in two variables is an ordered pair that is a solution to each equation in the system. And again, as we go through the video, you're going to learn a lot more about what a system is and what the solution is. So the first thing we want to do is determine what a solution is. So a solution to a system of linear equations is an ordered pair that makes both equations true. So it must make both equations true to be a solution. So we're going to more or less check this. So again, remember, ordered pair is always the x term followed by the y. So we're going to substitute into this first equation. It's 2 plus 5 is equal to 7. 7 equals 7, and that checks. So now we'll plug into the second equation. 2 times 2 minus 3 times 5 is equal to a negative 11. So now, 2 times 2 is 4, minus 15. 4 minus 15 is a negative 11, equals a negative 11. Since both equations are true when we substitute in that ordered pair, then this ordered pair of 2, 5 is a solution. Well, now we're going to check the second system. So this system says that negative 2, 0 is a solution. So let's check that. So again, it's the x followed by the y. So I get 0 is equal to a negative 2 times negative 2 minus 4. Negative 2 times negative 2 is a positive 4. Minus 4 is 0. And 0 equals 0, and that checks. Second equation, plug 0 in for y. Plug a negative 2 in for x plus 4. But a negative 2 plus 4 is 2. 2 does not equal 0. Since it does not make the second equation true, this is not a solution. It's not a solution. Okay, so a solution must make both equations true. So if you want to determine if it makes these equations true, go ahead and try it, and we'll determine if they do. And in this case, if we try this system, 2 times 1 plus a negative 2 is 2 plus negative 2 is 0, and 0 equals 0, and that checks. Then I'm going to plug 1 in for x, so the opposite of 1, plus 2 times negative 2 is supposed to equal a positive 5. Negative 1 plus negative 4 is a negative 5, does not equal a positive 5. Since this does not check, that's not a solution. So again, if you plug this one in and try it, go ahead and do that. You want to pause the video for a moment, and I will tell you that this is a yes. If you check it, it does work, that this is a solution. Now, the core concept here is to solve a system of linear equations by graphing. So the first step you'll do is you'll graph the equation on the coordinate plane. Then you're going to estimate the point of intersection and then check by substituting into the two equations. So in this first example, we're going to graph them, and so the first one has a y-intercept of 5 because we're just going to use slope-intercept form, and then goes down to right 1, down to right 1, down to right 1, and again we just continue that pattern and we go ahead and we draw our line. Now I graph the second equation, which is a y-intercept of a negative 1, and it goes up 1, 2, 3, 4 over 1, And as you can tell, it has a common solution of right here. So we name that ordered pair, which is the ordered pair 1, because that's 1 on the x, and 3 on the y-axis. And then we should check that to make sure. So again, we'd substitute 3 in for the y, and negative 2 times 1 plus 5. That gives me negative 2 plus 5 is 3. 3 is equal to 3, and that checks. And now I go again the same. 3 is equal to 4 times 1 minus 1. 4 minus 1 is 3. 3 is equal to 3, and that checks. So the solution we found of 1 comma 3 makes both of these equations true. So this is the solution to that system. Now, these next ones we'll go ahead and graph. Again, we're graphing using slope-intercept form. So this first one has a y-intercept of 3 and then goes up 1 over 2, up 1 over 2. Or we can go in the reverse direction also. And I draw my line. Now I'm going to use y-intercept of a negative 5. And then I can't really go down 3 right 2, so I'm going to go up 3 left 2, up 3 left 2. And as you can see, when we do that, it intersects right there at the point negative 4 comma 1. And again, I'm not going to check this one, but that's how we graph a system of linear equations. Now in number 4, what do you think we need to do here? Well, yeah, you should put them both into slope-intercept form. So this one would be y is equal to a negative 2x plus 5. And then the next one, I'd have to move that over. So it'd be negative 2y is equal to a negative 3x plus 4. Then divide every term by a negative 2. And we get y is equal to a positive 3 halves x minus 2. And then we'd have these two equations to graph, and where they intersect would be our solution. If we look at an application problem here, here it says, for the first tour on Monday, a museum sells 4 child tickets and 8 adult tickets for $128. For the second tour, the museum sells 6 adult tickets and for $72. Excuse me. Find the price of 1 child ticket and the price of 1 adult ticket. Well, we first have to set up our equation. So what we're given that 4 child tickets, we don't know the price of a child ticket, plus we buy 8 adult tickets, we don't know the price of the adult ticket, equals $128. The second tour, we had 0 child tickets plus 6 adult tickets for $72. Well, if we let x be the price of the child ticket and y be the price of the adult ticket, now we have this system of equations we can set up. If we want to solve this by graphing, we want to put them both into slope-intercept form. So again, the first one would end up being y equals a negative 1/2 x plus 16. And the other one, because it just has the variable y, would just be y equals 12. Well, we graph these. So the first one has a y-intercept of 16 and goes down 1 over 2. And the second one is that horizontal line of y is equal to 12. And if you notice, they intersect right here. And again, the x-axis represents our child ticket price, and the y-axis represents our adult ticket price. So the adult ticket price is $12, and the child ticket price would be $8. And that's using a system of equations by graphing to solve a real-life problem. Again, here's another example. You can pause it and look at it and graph it if you'd like, but we're going to go ahead and save this one for another day. So just to shorten up the video here, let's go ahead and have you open your student journals to page 135 and complete problems 1, 3, 7, and 10, and we'll check these tomorrow in class. Have a great evening, Titans. Good night.